We are going to talk about one of the most important best practices in building information modeling, the BIM execution plan, or BEP. BIM can be a very powerful tool in construction. It can support design coordination, clash detection, scheduling, cost estimating, and information management. But BIM does not become valuable simply because a project team uses 3D modeling software. BIM becomes valuable when the team has a clear plan for how the model will be created, managed, shared, and used. That is where the BEP becomes essential. A BIM execution plan connects BIM technology with project management. It defines the project goals, team responsibilities, software platforms, model requirements, quality checks, and information exchange procedures before the work begins. Without a BEP, BIM can quickly become confusing, inefficient, and difficult to manage. Different teams may model in different ways, information may not be exchanged properly, and the model may not support the actual project needs. With a BEP, however, BIM becomes an organized and consistent project workflow. The BEP helps the team understand not only what to model, but also why they are modeling it, who is responsible for it, and how the information will be used. So, the key idea for this slide is simple. BIM is only as strong as the plan behind it. The BEP is the document that turns BIM from a general technology concept into a practical project management system. Before modeling begins, the project team needs to answer several important questions. What software will be used? Who is responsible for each discipline model? What level of information is needed at each phase? How will models be exchanged, reviewed, and updated? These questions may sound basic, but if they are not answered early, they can create major problems later. For example, one team may use a different file format, another team may model elements at the wrong level of detail, and another team may assume that someone else is responsible for resolving clashes. The BEP helps prevent these problems by creating a shared set of expectations. It gives modelers, designers, contractors, consultants, and project managers a common framework for collaboration. A BEP is often developed in two stages. The first is the pre-contract BEP. This is usually prepared during the proposal stage. Its purpose is to show how the team plans to meet the owner's employer's information requirements, or EIR. The second is the post-contract BEP. This is prepared after the project is awarded, when the full project team can participate. Because more participants are involved, the post-contract BEP is usually more detailed. It may cover coordination procedures, 4D scheduling, 5D cost estimating, information exchanges, and model review processes. The main point is that the BEP allows the right information to reach the right people at the right time. It supports communication, transparency, schedule control, cost control, and better project delivery. A bad BIM occurs when the project team begins modeling without a clear execution strategy. In that situation, each team may create models in its own way. Designers, engineers, contractors, and subcontractors may work in isolation instead of following a shared process. One major problem is siloed and incompatible modeling. When teams work separately, they may produce duplicated files, conflicting model information, or files that cannot be easily combined. This reduces the value of BIM because the model no longer functions as a coordinated project resource. Another problem is over-modeling or under-modeling. If the BEP does not clearly define level of development or level of information need, the model may become either too detailed or not detailed enough. Over-modeling can make files too large, slow, and difficult to manage. Under-modeling can make the model unreliable for coordination, constructability review, or cost estimating. Legal and contractual issues can also develop. BIM models contain shared digital information, so ownership, authorship, and liability must be clearly defined. If these issues are unclear, participants may become reluctant to share their models. They may also disagree about who is responsible for correcting clashes or acting on model information. As the slide shows, these problems can lead to delay, rework, disputes, and even litigation. but perhaps the most serious consequence is the breakdown of trust. BIM depends on collaboration. When there is no clear BEP, collaboration becomes much harder to maintain. This slide summarizes the minimum components of a practical BIM execution plan. These components are based on the logic of the Penn State BIM Execution Planning Guide, which is one of the best-known frameworks for BEP development. The first component is project goals. The BEP should clearly explain why BIM is being used. These goals should be connected to measurable project values, such as reducing schedule duration, improving coordination, lowering cost risk, improving quality, supporting safety, or preparing information for facility management. Good BIM goals should be specific, measurable, attainable, relevant, and time-bound. The second component is BIM uses. Once the goals are clear, the team must decide which BIM applications will actually support those goals. These may include 3D coordination, 4D phase planning, 5D estimating, site planning, constructability review, or facility management support. The important point is that a project does not need every possible BIM use. It should select the BIM uses that provide real value for that specific project. The third component is roles and responsibilities. BIM requires clear accountability. A strong BEP should include a responsibility matrix that identifies who creates, reviews, coordinates, updates, and approves model information. It should also identify model element authors for important building components. This helps the team understand who owns each part of the model and who must be involved when changes occur. The fourth component is information exchange. BIM depends on the movement of information between participants. The BEP should define what information will be delivered, who will provide it, who will receive it, when it will be exchanged, and what format will be used. This may include native model files, IFC files, BCF files, upload milestones, coordination meeting schedules, and MIDP or TIDP requirements. Together, these four components make the BEP a working project document. They help prevent confusion and make BIM implementation more predictable and useful. This case study shows why a project-specific BEP is so important. The project was a high-density data center in the United States, delivered using the Construction Manager at-risk method. The owner required BIM, but the BIM expectations were not clearly defined. There was no clear employer's information requirements document, and the BEP did not provide enough guidance for the team. Because the BIM scope was vague, subcontractors did not know exactly what was expected of them. The BEP did not clearly define the responsibility matrix or the level of development requirements. As a result, participants were unsure about who was responsible for model creation, model updates, coordination, and clash resolution. The project team also had problems with information exchange. Important MEP data was missing, conflicts remained unresolved, and the team did not have clear cloud collaboration procedures. Because of these problems, trust began to break down, and the engineering phase was halted before the project reached 30% design completion. At that point, the general contractor's BIM manager intervened. The BIM manager organized a stakeholder workshop to stop the isolated modeling process and redefine the project's BIM uses. The team agreed that the most important uses were 3D design coordination and model-based constructability review. After that, the BEP was rewritten as a project-specific control document. It included a clear responsibility matrix, required subcontractors to assign BIM technicians, established weekly coordination meetings, and clarified financial accountability when installed. Work did not match the approved coordinated model. The lesson from this case is clear. A BEP should never be treated as a copied template. It should be a living project document that guides collaboration, accountability, and information exchange. When the BEP is clear and project-specific, BIM becomes a practical tool for project delivery. When the BEP is vague or missing, BIM can become a source of conflict.